Today we want to review the topic of completing the square, also known as conversion to vertex form. We have the quadratic x squared plus 4x minus 9, and we want to place that in the form a multiplied by x plus h to be squared plus k. Before we begin, we want to recall that a quadratic is of the form ax squared plus bx plus c. Before we begin, we want to recognize that a quadratic is of the form ax squared plus bx plus c. A would be the coefficient of x squared. In this case, a is 1. The 1 is usually not written, it is understood. B would be the coefficient of x, which in this case is positive 4. And finally, c would be the non-x term, negative 9. So we take note of this. A is equal to 1, b is equal to 4, positive 4, and c is equal to negative 9. So this is the quickest way to place a quadratic in vertex form. We simply use some formula. A is the coefficient of x. In this case, a is 1. H is equal to b divided by 2a. K is equal to c minus ah squared. In this question, b is equal to 4 divided by 2 times a is 1. That'll give it 2. So h is equal to 2. K is equal to c, which is negative 9, minus a, which is 1, times h squared. H was found to be 2 squared. And that'll give us negative 13. So in the end, we have x squared plus 4x minus 9 can be expressed as x plus 2 squared minus 13, where a is 1, h is 2, k is negative 13. In the next step, I'm going to explain where I got these formula from. Well, specifically these two. So let's look at this example. 4x squared plus 16x plus 13. The quadratic doesn't matter. We're going to focus on the right hand side. A, x plus h squared plus k. This is the format that we want to express the quadratic in. The first thing I'm going to focus on is x plus h to be squared. I'm going to expand this. When we expand x plus h to be squared, we're going to get x squared plus 2hx plus h squared. That is what our expansion gives us. Now we need to multiply each of these terms by the coefficient, which is a. When we do that, we're going to end up with ax squared plus 2ahx plus ah squared plus k. We remind ourselves of the quadratic, and now what we do is equate terms. The coefficient of x squared is 4 on the left. The coefficient of x squared is a on the right. So a becomes 4. Yeah? A is the coefficient of x squared. That is fairly simple. The coefficient of x on the right hand side is 2ah. On the left hand side, it is 16, or b. Yeah? Now remember, our quadratic is of the form ax squared plus bx plus c. So 2ah is equal to b. And when we make h the subject of the formula, h is b divided by 2a. And that is where we got this formula from. And finally, we have ah squared plus k is equal to 13, right? Which is really c. if we make k the subject of the formula, k is equal to c minus ah squared. And that is where we got this formula. So by expanding the right-hand side and the equating terms, we can get these very convenient formula to use to solve completing the square. So now let's look at another method for doing this. We know that a is equal to 2. I want to focus on the first two terms, 2x squared and 4x. So what I'm going to do, I'm going to place 2, which is a, on the outside, and I'm going to have x plus b divided by 2a inside the brackets, squared. This will work out to be 2 multiplied by x plus b is 4, 2a will also be 4, so that's 1 squared. As for the rest of the equation, it becomes minus 5 minus a multiplied by b divided by 2a squared. So what that works out to be is minus 5 minus a would be 2, and b divided by 2a is 1, so 1 squared. And so finally we have 2 multiplied by x plus 1 to be squared minus 7. Okay? So in this case, a works out to be 2, h works out to be positive 1, and k works out to be negative 7. Okay? And that's it. The final method for converting a quadratic to vertex form is completing a square. It is the most complicated of the three methods. So you want to try to avoid using this as much as possible. Only use it when absolutely necessary, or use it when the exam specifies that you must complete the square method. Now once again, in this method, we're going to focus on the first two terms. Now in this equation, a is equal to 2. So what we want to do is factorize a out of the first two terms. And what we're going to end up with is 2 multiplied by, in brackets, x squared plus 2x minus 5. Now what we want to do is we want to focus on these two terms. We're going to duplicate. We're going to bring this to the side. Now the reason we call this method completing a square is that we are looking for a linear factor where when it is squared, it will give us these two terms. It will give us an additional third term, which is c, but the purpose is to find that linear factor that will produce these two terms. So how do we find this linear factor? The first thing I'm going to do is divide by x. Yeah? And that will give me x plus 2. The second thing I'm going to do is divide by 2, okay, which will give me x plus 1. And so the idea is that x plus 1 to be squared will give me x squared plus 2x plus another factor. So let us expand x plus 1 squared. The first term squared will be x squared. The last term squared is 1 squared, which is 1. This is the third term that we will get using this method. And we multiply everything we see. 2 multiplied by 1, 2 multiplied by x, 2x. So indeed, we see here that when we expand this linear factor to be squared, what we're going to get is x squared plus 2x, which is what we have here. And this is why we call this method completing the square. My next step is to make x squared plus 2x the subject of the formula. So x squared plus 2x will give me the linear factor squared, x plus 1, to be squared minus 1. So now we have a new term for this. Now moving back to the original equation, what I'm going to do is, in the original equation, I'm going to replace x squared plus 2x with our new expression, which would be x plus 1 to be squared minus 1. Yeah? So I have replaced purple with blue. Yeah? We're going to continue. Minus 5. Now I'm going to expand the beginning of the expression. We're going to have 2 multiplied by x plus 1 to be squared, and then 2 multiplied by negative 1 will give us negative 2, and then we also have the negative 5. So finally this becomes 2 multiplied by x plus 1 to be squared minus 7, and we have converted the quadratic to vertex form using specifically the completing the square method.